Again. And exactly this is what it's going to be about, this talk. Bits and bytes on the field, zeros and ones in IT. Our speaker has looked at this and will tell us what the state of the art is in agriculture. Please, a round of applause for Fritz Dietrich Burkhardt.
Danke, Katha, für die schöne Anmoderation.
Thanks for the nice introduction. It's interesting to see that we have developers who work in this field. Luckily, it's only 3 or 4, so I can tell everybody else something of this. Right, shortly something about me. I got a bachelor in ecological agricultural science from Kassel. I dealt with the future development of agriculture, which is what I want to talk about in this presentation, and ultimately talk to you about this. Currently, I am doing a master's in Osnabrück. This is called Precision Plant Management. It's about sensor technology, agricultural science, profit management, and it's quite nerdy actually, and quite interesting. I put it into different sections. What can we do? I'm going to give you a little input on that. We can mechanically protect the soil. That's without software, that's simply analogously. We can move the machines so that they protect the soil a little. This actually was done with software, and it shows how a farmer drove over his field over a year. The white spaces are where he hasn't driven. And these machines are pretty heavy, and the soil doesn't really like that. And so we think about how we deal with this. And one trick we do is separating the growing area from the driving area. And there are where you create basically driving lanes on the field. And I did my bachelor thesis, and that's why I didn't speak here last year, because they didn't want me to talk about this here. We can also do platooning, and that's quite nerdy already, because we have 2 machines here, quite just regular machines that are controlled by a single driver. They are connected electronically, and the company Acker has developed this, but it's quite, for legal reasons, it's quite tricky to do this. The question being, how do we get the second machine, which doesn't have a driver, onto the field? That's too much effort, and, well, agricultural workers aren't very expensive, so this has been put on the back burner again for the time being.
But this should be taken back again when it gets ready. But I think it's really interesting, and that has been developed a couple of years ago. What's been in existence for a couple of times, since 1999, 2000, is automatic track guidance via GPS and RTK. On the right-hand side, you can see how precise this is. So you can basically up to 2.5 meters, you can guide the vehicle on the field, but that's rather expensive. So the so-called SF1 signal, what you see on the slides, is for free. It doesn't cost any money. With 26 centimeters is rather precise, but it's still not exact enough for high precision agriculture. So I just put it now on the slides so you can see how the case where the driver sits within the tractor, how it looks like. It could be even more screens within the tractor in the future.
Wir können auch Echtzeitertragskartierung machen. Ziemlich spannendes.
We also can map the field via real-time cartography, and it directly maps the field where I actually got my crop. And these files are sometimes transferred to web apps directly in real time, and sometimes they can even be gotten by the driver themselves in real times.
In einem Fahrmanagementsystem oder in einem GIS-System.
And via a GIS system or a driver management system, you can even derive information. For example, when you see the red parts on the field, you can even connect this information with other maps. On the left-hand side, you see the various technologies that are used with this technology, with these application maps.
Da fährt dann meistens so ein ganz witziger Wagen, gezogen von einem Geländewagen.
There's a very funny carriage that drives over the field and
measures the electrical resistance and conductibility, and that's actually useful for figuring out the value of the land. And from all of this information, we can derive how good the yield of the land is. And you can see on the right-hand side this construct on the tractor, and this measures the chlorophyll in the leaves, and from the amount of chlorophyll it can derive information about the health of the plants. And while it's driving in real time, it can adjust the amount of fertilizer that it puts out at the back of the car. And of course, we can build new machines to our threshers. Looks very much like a transformer, but it's not the interesting picture. The much more interesting picture are the two at the right-hand side. And these are models of the insides of a thresher or a machine that cuts wood into tiny pieces. And these machines can calibrate themselves and figure out how much energy they have, how much capacity they have for doing their work themselves and control themselves. And there is actually a world championships of threshers, and I know some people who just this year beat the best thresher driver with their autonomous thresher. And it's being studied at the university where I did my bachelor's. We can hear how sharp these knives are, and we can, if you look at the image on the right, the red drum, that spins extremely fast, and we can put a mic there and we can hear how sharp the knives are.
On the bottom part of the image, you can even measure how dirty the crop is that is gathered by the thresher. That is also very important to know because it determines how long you want to store the crop and the quality of it. I've already talked about this aspect. The maps we create in real time, they are documented, and there is a huge interconnectivity between all the devices. And obviously this costs a lot of money, but the prices for produce are very low, which creates other problems in itself.
dokumentieren die Bauern ihre durchgeführten Feldarbeiten nur 34.
It's very interesting to see how
Weil die wirklich guten Softwarelösungen kosten
agricultural farmers document
Zahlen.
their stuff, and there is only 34% of agricultural farmers in Germany who actually document their produce electronically.
Die Büroarbeit in dem eigentlichen Bauerndasein
The office work when you are a farmer is close to 70%. So if you map that to the electronic work done, this is really incredible.
sozusagen auch
So basically you need to document every step you do when you work as an agricultural farmer. You need to do this to get subventions by the European Union. So it's similar to when you go to financial
auf jeden Fall auch recht
part.
leicht noch Automatisierungspotenzial, dass man am Ende einfach die Maschine vielleicht mit dem Webportal verknüpft.
There is still a huge automation potential so that you maybe also can connect the machine to your web portal and so on. But I will talk about this later, get to you into a discussion about this.
Wir können Inhaltsstoffe messen. Dieser graue Kasten oben links ist ein
Very interestingly, you can even measure the contents that you use on the field on the top of the slide.
Feldhäckslers, der
You can measure within a machine that cuts the produce into little pieces. You can even measure the dryness of the produce. And on the same time, the sensor, which is mobile, that you can attach to any device you want,
ausgebrachte Güllemenge regelt.
you can even measure the fertilizer you use on the field. So that also determines how fast the tractor moves on the field, or if the pump is working slower or faster.
Mit eigentlich abgefahrener Technik.
So you can see with crazy technology you can have very good results, which leads us to the next slide. The automatical
Oben an dem
loading of the vehicle.
sitzen mehrere Kameras, meistens
There are several cameras on the part where the cut grass gets out of the cutter, which is loaded into the vehicle.
der Fahrer ist vor allen Dingen in der Nacht ziemlich
And the driver sees actually a screenshot of this. And this is very good when it's during the night, when the air is not really well, when the visibility is very low.
teuren Bildern, zeichnet
And so this is very useful for the driver.
auf dem grauen Anhänger nach, wie voll der Anhänger ist.
And in the newer systems, there is even a green line which indicates how fully loaded the vehicle is. For this, you need the machines to talk to each other, which you can see in the following picture. That's how you actually sit today in a current tractor. So the driver actually only supervises what's going on the field.
Fahrer sind ein bisschen korpulent, vor allen Dingen
The most tractor drivers are maybe rather rounded, so to say, because they're sitting all the time. And it's rather comfortable. You can even put up the seat, and it's rather comfortable to sit. So you supervise the communication of the machines, basically, on the field.
Maschine vorne.
The azure line is actually, on the picture, is actually the machine on front. And the machines exchange data. That's how the app developer actually imagines this.
Ein Praktikum letztes Jahr bei der Firma GG.
When I did an apprenticeship last year by the company Zondia, we used a very long time to actually install all these machines because they had a hard time to connect to each other. So you see, there is much stuff you still need to develop. This also applies to drones on the fields. They're really cheap. You can use them in very different situations. For example, on the right-hand side, below on the bottom, you can, on the left-hand side, below on the bottom, you see how a tractor drives up front and the drone actually follows. And the drone can track what's going on the field, if there are stones or animals on the field.
Wieder in der Wiese abgelegt und dann
So especially young animals that are still in springtime, they lie on the field and sometimes they don't run away when a tractor comes.
Problem daran ist,
And the additional problem to that is that you're not allowed to touch them because they will get repelled by their mother.
einfach Techniken zu entwickeln.
So you need to actually develop a technology that discovers these young animals on the fields.
Die Techniker,
There is a company called Pöttinger which develops this technology, even a supersonic system that will actually stop the machine and determine if there is an animal on this field and stop the machine in its tracks in order to protect the animals.
Zusätzlich können wir zum Beispiel auch Herdenkontrolle machen über Drohnen.
In addition, you can do even herd control via drones, which is kind of easy. The drone is equipped with a camera, and the computer program or the software realizes that black dot is a cow on the field, and the green stuff, that's the field. So that's also very useful to count the cattle on the fields, especially when they are, so for example, in the Alps, in regions which are not really easy reached. Such example, in the United States or in Australia, there are many cattle that are held without any restrictions and they roam freely on the fields. That's very useful to use drones.
In addition, we can bring things into the field with drones. This funnel with these balls, these are a type of wasps which you can use to counter a certain kind of bad bug whose name I've now forgotten. And this wasp is put into the field, is happy, kills all the bugs and goes away to do something else, killing more bugs that we don't want. Or with a low-flying drone and a certain camera, we can figure out the health of plants, which is quite interesting because 20, 30 years ago, you treated a field entirely homogeneously. You had this field and you always did the same thing on that. And now we are basically down to thinking in pixels. You think of one of these yield maps and every pixel has a different color and a different property, and you can gain information from that and you can treat these things separately. And if you're doing biological agriculture, organic agriculture, and you're not using glyphosate everywhere, then, well, you don't have to anymore because you can figure things out much closer and you can fly very high and figure out where the nasty bugs are. And you've never got a field that is completely free of bad bugs, but you can pinpoint them and deal with them there instead of everywhere. So where do we go from here? Well, R2D2 on the field. This device is being developed by a French company and it already exists. I've seen it for the first time in action this year. It fell over a few times. There's a fairly high center of gravity on this device, but it's still quite cute to see how this drives over the field and removes the unwanted growth. Here, the robot. So there are very diverse use cases for robots, and it's quite interesting to think about robots and track guidance. And these robots can very, very precisely, by driving over the plants, deal with these fields. And you don't need drones, you don't need tractors. And this is being developed at my university as well. They do plant inspections and they take soil samples, and those are quite important, those soil samples. Generally, you just send students and they have to put this huge metal plug into the ground and then pull it out and take out soil samples, and you have to bring them to the lab and do it there. And with these robots, you can take soil samples, analyze them in the robot, and basically leave the soil on the field. So the samples stay on the field. And you can scale this up. Robots small and large. Case is developing this. It's it's out in the field. Many years ago, that was still just a model, but that's where we're going. Small, large machine autonomously on the field. It's tricky to find tractor driver. They're not necessarily the smartest, and they certainly don't have the most amazing job. So in future, we can leave them behind. Maybe that's not too bad. And then there is also the swarm concept. The top image is not real. The truck is, but what he's carrying isn't. And that's the idea. So the truck drives up, drops 3 autonomous machines, and they, as a swarm, deal with the field.
There's also the small swarm concept, where you have a small trailer with a small robot that is directed by a satellite, and they load up their data to the cloud. And the farmer can actually look at it on the tablet, what's gathered on the field.
Jetzt aber noch ein bisschen weniger Technikbesoffenheit.
So now we go a little bit to another field. We leave the tech hype. And in our agriculture, it's not all on the bright side. Maybe you know these numbers. The left graph shows
Also der globale Index an Insekten.
the amount of insects globally, and the orange lines shows butterflies. And the right-hand side, you see the amount of endangered plants on the planet. Just let it soak in.
Die ganzen Techniken dienen ja unter anderem auch der Dokumentation für EU-Agrarsubventionen.
All these technologies serve also to get subventions by the European Union. So the subventions are also determined by the size of the land you own. But citizens also want that farmers do something for the environment, which might be difficult. You know, maybe the discussion. I'd like to give you here a quote by a CEO of a big company. We have 8 million of farmers in Germany who do not own land, but they have some kind of imagination how agriculture should be done. And we have 280 farmers who actually do this. And the problem is they don't talk with each other. That's the current situation. They don't talk to each other. There is an imagination how agriculture should be done. Maybe you have it as well. Luckily, changes are slow. Change is slow. Those quotes, which I can't see from my translator's booth, please let them soak in. So the community of the farmers have actually preached to use new technology and fertilizers, do monocultures. We dominate the earth. And now we noticed that this doesn't work as well as we hoped. Nature has developed resistances against fertilizer and other stuff. There are some plants that aren't destroyed by... Plants do not destroy glyphosate, and they soak it in and take it up and store it. And so what do the farmers do? On the left-hand side, you see the monoxide that we actually inhale. This has remained constant over the 25 years. This monoxide comes from the earth, and it comes from the earth and it goes back to the earth. But this leads to that the nitrate in the ground is being washed out. So it's not monoxide, it's nitrogen. So we need to ask our question, we need to ask ourselves, what kind of agriculture do we want? We have the problem that prices are very low. Fertilizers are cheap, and gasoline is expensive. Fertilizers are cheaper and cheaper. And everything is very cheap and readily available. And during the milk crisis, over the years you have preached, we need to grow, and suddenly you have too much milk and no one wants to pay for it.
Quickly, it wasn't fertilizers, it was plant protection stuff like glyphosate that he was mentioning before. Okay, so we should ask ourselves how we want to define modern agriculture. And I want to open a discussion here at the Q&A or just afterwards next to the stage or even per email, Skype, whatever. I want to talk to you. There are platforms. We should ask ourselves, does modern agriculture enslave the earth? Do we not look at the soil, the earth, as a living system that has been growing for thousands of years? And maybe we will stop calling it nature and just calling it substrate? Or do we want to have an agriculture which uses the naturally available synergies like these wasps that I mentioned, ecological agriculture which works with nature and uses the tools of nature? I'm of the opinion that, thinking about the quote that I mentioned before, that we need a sort of societal contract which defines how agriculture works, and that involves everybody here. You are very capable people. I've seen amazing talks, and I'm very impressed by all the things that have been done and the people that are here. And maybe you should think about what you can do. And I heard yesterday that friends of mine are doing techno gardening. They have a garden which is completely autonomously managed. We can directly buy from farmers. We can work towards biodiversity and ecological farming. There was a talk here about agroforest systems, and here's an interesting thing which is really important. We have 7.5% ecological farming, and the question hasn't been answered, what is modern agriculture? And I don't think it's very modern if the big pie chart is being paid for already having something, for the size of the farm. The smaller bit of the pie, that's where biodiversity and ecological farming is being subsidized. And for me, that needs to be exchanged, and that's something to think about. There is applause. So really, it's about making our agriculture fit for our children. We'll see how it develops, but these are a few ideas. You know, you can go look at cows, whether you eat them or drink their milk or whatever. You can just go there, take a look, go to a farmer and tell him, I know how to do software. I'll write you some software that'll tell you how much of these poisons you can save by doing ecological farming rather than what you're doing right now. I'd like to have some questions from you now. Thank you.
Vielen, vielen, vielen herzlichen Dank von Treckerfahrer zu Treckerfahrer.
Thanks from tractor driver to tractor driver. This was a really interesting presentation. We have time for just one question. But then you can go to the speaker and ask him further questions. And he really welcomes you to join him for more discussions. How much phosphate and nitrogen you have for the following years? How much is left? And whose possession is it?
I cannot answer the nitrogen question directly. I'm sorry. I'd have to research that. As far as I know, it's kind of like oil. We are still finding plenty. about privacy, it's an interesting topic. It keeps the farmers cautious of new technology, and something has to be done. The farmers want to keep their data with them, and they want to know if Mr. John Deere is looking at that, or Mr. Acker, and that's kind of important. And the data belongs to the farmer, and he's the only one who can decide about that. And he can decide to sell it, but then he should be reimbursed for that, monetarily or with a new tractor or whatever. Thank you, and thanks also for listening to the English translation from the Talk Nullen und Einsen auf dem Acker.